could be easily seen by having it be 1 over n minus 1 over n plus 1. So there's usually an adding or subtracting sign between two equations. So when plugging in each term from 1 to however many numbers you want to do, you could figure out if it's a telescoping series. For example, for this, when you plug in 1 to the original equation, it would give you 1 over 1 minus 1 over 2, which is seen in the first parentheses right there. And then continued on, you would plug in 2 and 3. And then since I ended up stopping there, you could continue on if you want to, or you could stop there if you already see the pattern. And then have the nth original equation set up as the last one. When looking at this, you could see some of the terms crossing out. For example, you could see the negative 1/2 cross out with the positive 1/2 right here. And then you could also see the negative 1/3 cross out with the positive 1/3 right here. And then you could also assume that the negative 1/4 would cross out with the 1/nth, which is the next term. And then already assuming that the negative 1 over n plus 1 would cross out with the next term after that. If you were to continue on the list and plug in more n's. So this would be leaving you with 1. So your answer at the end is 1. So S of n equals 1 minus 1 over n plus 1. And you set up the limit as n approaches infinity of 1 minus 1 over n, which equals 1 given to you at the beginning. And this would converge infinitely as a series, and it converges to 1 because that is the solution you found out. Geometric series is another series that should be known. For geometric series, you should know that r, absolute value of r, if it's greater than or equal to 1, then the series diverges. If the absolute value of r is less than 1, then it converges. And you would set the radius of convergence between -1 and have it less than 1. After that, the sum that you find, to find the sum, you would do a over 1 minus r. For this example, since you know that the r would be 1/2, because the original equation of 1 over 2n, when you take out the n and leave it as the exponent as a whole, because you could do that for the 1, because 1 to the nth of anything would be 1. You take out the n and your r on the inside would be 1/2. Since 1/2 is less than 1, this would mean that the series is a geometric and it converges. So to figure out the sum as it converges, you would plug in 1/2 over 1 minus 1/2, which is a over 1 minus r, and that's given to you from this equation. So figuring out the sum, you would have to calculate 1/2 over 1 minus 1/2. So it's 1/2 over 1/2. Another test used would be the nth term test for divergence. For the nth term test, you need to know that if a limit as n approaches infinity of a of n is not equal to 0, then the sum of n equal 1 as it approaches infinity of a of n, it diverges. But if limit as n approaches infinity of a of n does equal 0, then that doesn't particularly mean that it converges. So an example of this would be this sum as n equals 1 approaching infinity of n over 2n plus 1. You would do L'Hopital's rule and have it be 1 over 2 because of the n's. When you do the derivative, it would be 1/2. And you'd know this diverges because it's a specific number and it does not equal 0. If this were to equal 0, you would have to continue on with the problem equation. Thank you for watching. That was the end of 9.2 series. Continue to the next video to see the 9.3 integral test and the P-series test.